1980s and was officially canceled in 1993. While short, the program sparked a serious development effort towards the technologies needed for usable hypersonic flight and space access. There were three main challenges identified. The first was the development of a new, lightweight yet strong material which could withstand the extreme heat of hypersonic travel. The second was the development and testing of a supersonic and hypersonic scramjet engine. If this engine was successfully developed and tested, then the third challenge is the integration of it into a flight vehicle while maintaining operability. The NASP would open a new world of potential for aerospace applications with the technology it utilized. Potential missions ranged from military reconnaissance and transport to in-space operations and even further to commercial travel. With such a pivotal vehicle being designed, there were many major players who contributed to the program, such as NASA, McDonnell Douglas, and General Dynamics. This reverse engineering project is on the conceptual design level. The goal is to determine how close our current technology is to produce a feasible vehicle which completes the goals outlined during the NASP program. This assessment is completed using the generic aerospace vehicle design process developed by the Aerospace Vehicle Design Lab at UTA over the last 20 years. The AVD Lab's design process can be summarized by a repetition of a generic design refinement process in which selected vehicle designs, mission profiles, and technologies can be integrated, evaluated, and screened to determine which option is best. The results are then passed into the next refinement process, where the parameters are further defined and evaluation takes place again at a higher fidelity level. In the conceptual design phase, the AVD Lab repeats this refinement process twice, and this study will focus on the initial phases, project initiation, and parametric sizing. The original ascent profile was reviewed and modifications to it were made to better suit today's technology and understanding. Subsonic and transonic flight used a rocket to assist in the ascent, and this use is maintained. The original design had its scramjet in use up until Mach 20, which is much faster than the Mach 12 upper limit, which scramjets are theorized to have today. So the main change is the point in which the rocket engine takes over, providing full thrust to the vehicle. Mach 8, 10, and 12 are of interest for this critical flight phase. For the vehicle design, the McDonnell Douglas NASP configuration is chosen. The slenderness of this vehicle, designated as the Greek letter tau, is another point of interest for this design as it greatly affects the aerodynamics and integration capability of the engines. The original McDonnell Douglas design had a slenderness of around 0.09. For the study, values of 0.08, 0.10, and 0.12 are used. To evaluate the vehicle's performance along its descent trajectory, aerodynamic characteristics and propulsion system performance are estimated. With these, the vehicle fuel weight fraction can be determined. This analysis is used within an iteration process where the vehicle's size and weight are iterated until the design converges on the required vehicle weight and volume to complete the mission. The last trade variable of interest is the payload weight. It was of interest to determine what a feasible space access vehicle would be if it were to be a demonstrator only with no payload, as well as if it were to be a space freighter which carried 50,000 pounds to orbit. The trade studies were completed and generally agreed with the original NASP design, though never officially finished. It was in the right ballpark of around 900,000 pounds. Follow-on studies past the NASP program indicated that some vehicles could stretch into 1 to 2 million pound range depending on the technologies implemented. Results agreed with this trend as well. Overall, it was determined that the AVD Lab sizing procedure can successfully size space access vehicles with reasonable accuracy, and the analysis models and methods used represented realistic performance metrics by today's standards, indicating a NASP configuration could be feasible in today's world.